This lecture will focus on physical and chemical properties. The physical and chemical properties of matter are determined by the interactions between atoms and or between molecules. So what am I talking about? Well, if we look at two atoms, for example, two helium atoms, what are the interactions going on? We have attractions between the positively charged nucleus and the negatively charged electrons of the two atoms. We also have some repulsions between the electrons of the two atoms. If we're talking about a molecule, let's say water, then we can talk about interactions between two or more molecules. There are attractive interactions between two water molecules. Hydrogen bonding is the most important one. And it's all these interactions that determine the properties. So why do we care? Because then we can, if we understand a sample at a molecular level, we'll be able to predict the behavior and the properties of the material much better. For example, water is pretty incredible actually. For as tiny as a molecule as it is, it's got some pretty amazing properties. So it should be a gas according to its molecular weight, but of course it's a liquid under room temperature conditions, and that's because of the interactions between the water molecules, the hydrogen bonding. It's called the universal solvent because it has such a strong affinity to dissolve so many things. It has such a high surface tension. I'm sure you've probably tried floating things on top of a water surface. Again, all those properties are due to hydrogen bonding. So the first thing we're going to do is separate properties that we talk about from physical properties or chemical properties. Pretty self-explanatory, but a physical property is a property that you can observe without changing the composition of the material. So when you use any of your five senses, smell, sight, touch, any of those things, that's a physical property. You can describe the smell or the hardness, the feel of something without destroying its chemical composition. A chemical property, in order to understand whether or not a substance undergoes chemical change, you've got to make it change chemically. So chemical property is a property that can be observed only by changing the composition. So if you want to know if something's flammable, you have to try to burn it. So what are some examples of physical changes? Things like ripping up or cutting up a piece of paper. Any change of state is a physical change. That's an important one. A lot of students get that mixed up. For example, when you melt ice, that is a physical change. You still have H2O. You haven't broken any chemical bonds. What you have done when you've changed the state of matter, for example, when you boil water, is you've simply affected those intermolecular attractions between different molecules, okay? You've loosened up the attractive forces so that in the gas phase there's more space between all of the molecules. As I said before, chemical changes break chemical bonds, and so some of the common ones, burning or combustion, rusting is a chemical change. How do you ask, some of them are obvious, like burning's obvious. They won't always be obvious. How are you going to be able to tell? A chemical change is not easily reversible, okay? So if you paint your bedroom wall, that is a physical change because you could paint back over it or you could remove the paint. If leaves change color, on the other hand, it's a chemical change because no matter what you do to that leaf, you are not going to get the original green leaf back. So that's it for the overview of physical and chemical changes.